Okay. I want to do a couple things tonight, especially word problems, but if you have the opportunity in the chapter 9 module in Canvas, there's a worksheet. I'm going to be doing as many of those as I can tonight. They're word problems from chapter 9. So I sent you an announcement, asked you to download that if you can. If you didn't, fine. If someone can put the questions in the chat, that'd be cool, just for those people who don't have it. All right. But what I want to spend is a few minutes showing you some math magic. Okay. You will not be accountable for what I'm going to write on the board for the next 5 minutes or 10 minutes. So you don't have to take notes unless you wish to. Okay. So I want to take this ax squared plus bx plus c equals 0. Okay. A standard trinomial. Okay. And wait a minute, we got to pause. There we go. What happened? Ah, come on. Boom, boom, boom. Okay, suddenly, somehow, my whole camera, this is Carmen's fault.
What do you mean? What did I do this time?
I don't know, this threw me out.
We can see you.
You can.
I can
Well,
see you on both the cameras.
But I can't see you, and I can't see my magic screen. Why can't I see my magic screen?
Carmen's fault.
So every time something bad happens, it's gonna come on me now.
You got it. Remember, I rolled the dice. You're it for the night.
I'm the bad luck charm today.
Right. Hang on. I got to pause this. Okay. I want to solve this for x. There's no numbers. I want to get x alone in a legal mathematical way. So the first thing I'm going to do is I'm going to subtract c from both sides. And I'm going to get ax squared plus bx equals negative c. Okay. Then I'm going to divide everybody by a. So I have x squared plus b over ax equals negative c over a. Okay. Now I'm going to have to write smaller, but now I'm going to use completing the square. We talked about that. We talked about how you do half times negative b over 2a, or negative b over a, and you get negative b over 2a, but then we square it. And it's that squared thing that we add to both sides. So that gives us x squared plus b over ax plus this mess, which I'll call, well, okay, I'll call it negative b over 2a quantity squared equals negative c over a plus negative b over 2a quantity squared. Now let me show you what I did. Okay.
Hold on, Mr. Foster.
Yeah.
Can you use a darker marker for that red portion? Because I can't really see what you did.
No,
exactly
I don't. I want it to stand out, and I don't. Do I need another red? Hang on.
I can't really see it
Yeah.
either.
Okay. Hang on a second. I will just put in more ink.
That's a fancy pen then.
What? Oh, these are, they cost more, but you can actually refill them. All right. So let's see what we got. Okay, so I moved the C to the other side, divided everybody by A. Then I said I was going to complete the square. It may take a minute or two for the red to come through, but you're doing half times B over A. That was what we said, half times that number, which was B over 2A quantity squared. We don't need the little minus there. That's okay.
That's better.
Okay. Okay. So B over 2A, and then we had to add that to both sides. Now, one of the things about completing the square was, in order to factor this, we didn't have to think much. We just use that quantity. Whatever that is what this will factor into. So this will become X plus B over 2A quantity squared. So this will factor into this, and you don't have to think about it. Okay. It'll be that thing before you squared it. Always. Equals. Now I'm going to switch this around. This is B squared over 4A squared minus C over A. So I took the right side here and I squared this. So that was B squared 4A squared, but I put it in front minus C over A. Okay. Now we're going to have a test. Oh, we had a test. Whatever. Yeah, we're going to have a test on if I told you how to add those two. If I said, hey, you need to be able to add those two fractions or subtract them in this case, then you would say, oh, I need a common denominator. Well, the common denominator is if I multiply this by 4A and this by 4A, okay, top and bottom by 4A, I'll have a common denominator of 4A squared. Okay, so I'm going to come up here and have to erase my notes. So use completing the square to get that quantity squared. I'm getting a common denominator. So let's call this X plus B over 2A quantity squared equals, I'll get out of the way, this is B squared minus 4 A C all over 4A squared.
Did you start the recording again?
Did
Yeah,
I?
it's recording. Okay.
Yeah, I did. And remember, don't lose sleep over this at all. And there may be somebody who does it better than me. I'll tell you what to look up on YouTube if you really want to. But so this was a common denominator, so I added these together. So this became B squared minus 4AC on top over 4A squared. Some of those pieces should begin to look familiar to you. Okay, where have I seen B squared minus 4AC before?
The quadratic formula.
Inside the quadratic formula, right? So we're going to square root both sides to get rid of the square power. So that gives us X plus B over 2A equals, remember, you got to put a plus or minus there. Instantly, if you square root both sides like that, you put a plus or minus, and you have a big old giant B squared minus 4AC all over 4A squared. Okay, now we can take this apart. We can take this radical apart. I'm going to do two things at once. I'm going to subtract B minus 2A to the other side. So I'm going to get X equals negative B over 2A. So I subtracted B over 2A from both sides, move it over here, plus or minus. I'm going to take the square root apart, and this is going to be the square root of B squared minus 4AC, and the square root of 4A squared is 2A. Okay, so take the square root apart, which we're allowed to do. The numerator just stays ugly, but the denominator is the square root of 4a squared, which becomes just 2a. It's a perfect square. All right, we're almost done. I'm going, hey, look, they have the same denominator, so I could push them back together. X is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And that is how mathematicians develop the quadratic formula. Okay, they just use some basic algebra and they use completing the square and common denominators and all the rules we've talked about. So there's the quadratic formula. Okay, and it just came out of basic algebra steps that theoretically we know all of them. Now, maybe you couldn't do it by yourself, but at least you should recognize the majority of the steps. If you want to see somebody else do it, maybe better than me, look up something like that says derive quadratic formula. Find something on YouTube, something that says that derive the quadratic formula. And there's got to be like 4 billion of them, and just see if somebody did it better than me, different than me, a little clearer. But you are not responsible for this at all, but you should know that a lot of the math formulas that we give aren't just, they didn't come because somebody was smoking peyote. They came because somebody used some good algebra skills, some good math and algebra skills. So that's it. Okay. Any questions before I erase this? No. Okay. Okay. Last week, I started something called Projectile Motion. And basically, it was a rocket shot into the air. Now, it doesn't have to be a rocket. It could be you throw a ball up into the air, you throw a spear up into the air, anything. Okay, you shoot a gun up into the air. Generally, its path will go up and then come back down. Its path is what we call a down parabola. Okay, its path will always look like this. And we change our axes. This is now the time axis, not the x-axis. What used to be the x-axis, we now call it the time axis. And what used to be the y-axis, we now call this the height axis. Okay, so we're measuring height compared with time. And we can ask all kinds of questions, and I'm going to get to some of those tonight. Okay, now a little bit of physics. I remember when I got into some of my upper math courses, they started doing this right away. And I'm just going, huh? What? I didn't understand anything that was happening. Okay, I did not have a strong background in science at all. And yet here I am taking all these dumb math courses. You need a little bit of background, and that's kind of what I want to give you over the next couple of evenings, is a background in the physics of this. Because as you go further into math, you will see this. So it's good that we hit it lightly now and a little bit harder the next time and a little bit harder the next time. Okay, The first thing we're going to write this as a function. H of t equals. Now, let me get my notes. Where'd it go? There it is. Okay. H of t, this is a function. This is not h times t. This was h of t, like we used to write f of x. And that told us, oh, you're going to plug in something. Well, this is the function height at a certain time. It's negative 1/2 gt squared plus, don't panic at all, okay, v naught t plus h naught. Now, I told you I have to give you the whole thing because you're going to see this in your physics classes. You're going to see this in your advanced math classes. This is the whole thing. The first term here shows what gravity does. G stands for gravity. Okay? Gravity eventually always wins. No matter how hard you shoot the rocket up into the air, it goes up, but eventually gravity stops it. Okay, slows it down, stops it, and then brings it back to the ground. Almost always gravity wins. So this first term is the gravity term. That's what G stood for. Okay, times t squared, which is time. Now, some vocabulary. This V sub 0, it's also pronounced V naught, N-A-U-G-H-T, or it's V sub 0. Okay. It's pronounced V naught because we got a lot of our original mathematics from the British. And they, instead of saying 0, they say naught. Okay, naught, N-A-U-G-H-T. So V naught, H naught. That's how those are pronounced. Or H sub 0 if you want to be American about it. So you have V naught or H naught or V sub 0 or H sub 0. Doesn't matter. Okay. And what each of these stand for, the V sub 0 stands for the initial velocity. Now, velocity is the speed that, let's say you shoot the rocket up or you shoot it out of a rifle or something like that, shoot the bullet out of the rifle. Its initial speed is really fast, but then gravity eventually wins, slows it down and brings it back. But at the beginning, when you pull the trigger or when you immediately fire off your rockets or whatever you do, it's going that fast. So that stands for initial velocity. Velocity is speed. Okay. H naught or H sub 0 is called the initial height. Okay. The initial height. If it's on the ground, then that means H equals 0. The initial height, H sub 0, H naught is worth 0 because it's on the ground. But what if it started, at the top of a 2-story building? What if your rocket started up here? Okay, then your H naught, your H sub 0 might be something like, I don't know, let's say 35 feet. Okay, it all depends on where it starts. So coming back to here, the thingy in front, okay, stands for the force of gravity, how gravity affects everything. Okay, Newton is the guy you can blame for on this. He's the guy who figured all this out. V naught or V sub 0 is the initial velocity. Okay, remember it'll start fast and always slow down. And H naught is always the initial height. Okay, and then it goes up and comes back down again. If we tell you it's on the ground, that means H naught is worth 0. If it starts on the ground, initial means starting. Starting. Where did it start? Okay. All right. Now, before you panic too much more, I will always give you this gravity thing. Always. Okay. You don't have to worry about it. In fact, I'll always give you this formula. You may have to fill in one or two things. I do need to add that in physics, the force of gravity is different depending on the planet that you're on, or depending on if you're using metric system or feet and inches, that kind of stuff. Okay. But if you're on the moon, it doesn't have as much gravity as if you're on the Earth. Okay. Or if we're on Mars, it doesn't have as much gravity as Earth, but it's got more than the moon. So while the same basic formula will work, okay, this G number will be different depending on the planet you're on. Okay. If we were on Neptune, we'd all be dead because the force of gravity there is so strong, we'd just be crushed. Okay. But the rule still works, we'd just be dead. Okay. So that would take all the problems away. I will always give this part to you. Always. So let's
Professor, quick question.
yeah.
What is the function? You have a H and then parentheses T.
H
T or
of
something?
T. H of T. That's a T. That stands
Okay.
for the time. So this is, excuse me, the height at a given time.
Got it. Thank you.
Okay. All right. So on the handout, the first problem, and if you didn't get it, if someone could copy and paste that into the chat, that'd be great. Okay. It says number 1, it says a projectile is fired straight upward from the ground. Okay, its height in feet is given by, so it tells us H of T equals negative 16 T squared plus 96 T. And because it said from the ground, technically there's a 0 out here. Okay, so let's take this formula apart. This is gravity. This is the force of gravity. This is the initial velocity. And this is the initial height. That's
Sorry
what
to
all of
interrupt
those
you.
stand for. Go ahead.
So on the last one, you had negative 1/2 G. Where
That's built into the 16. That's built into the 16.
Okay, got it.
Okay, I'm gonna give you the gravity thing always, so you don't have to worry about that negative 1/2 G crud. I'm gonna give the whole mess to you.
Cool, thank you.
Okay. Yeah, you get into physics class, they'll make you calculate it and do all kinds of other crud, but I'm not gonna. So that's what this stands for. This is the height at a given time. At some time can be found by this formula. We left off the initial height because it said on the ground. All right, so that's the first problem. Part A, when does the object hit the ground? Okay, well, let's go back. Here's my drawing. It came from the ground, it goes back up, it comes back down. It starts on the ground, and later it's going to hit the ground. Okay, we know that. So we want to know when height is 0. So that allows us to change this equation. Instead of H of T, we'll say the height is going to be 0 at some time if I solve that equation. Notice solving this equation will solve for T. Okay, so This is 0. This is where it gets a little confusing because it said hit the ground. I know this is 0. When is it going to go up? And when is the height going to be worth 0? So now all I have to do is solve that. Personally, I like my t-squareds positive. Okay, you can do whatever you want. I'm going to make it 16t squared minus 96t equals 0. I'm just going to bring everybody over to the other side by subtraction. Okay, I'm going to factor out a 16t. That gives me t minus 6, I think. So I factor out a 16t, I get t minus 6. Yeah, factor that out. So I say either 16t equals 0 or t minus 6 equals 0. Well, divide, this gives me t equals 0 because you divide both sides by 16. This gives me t equals 6. So we need to take these apart and think about them. What do they mean? We got these two answers when we said the height is worth 0. The height was worth 0. We got these two answers. So that makes sense. When time is 0, height was 0. It was on the ground. And then it went up and came back down. So when time was 6, height was also 0. That's what that's trying to tell us. That's what all of our algebra is trying to tell us. So the question says, when does it hit the ground? It hits the ground after 6, I think the units were seconds. Hits ground. Whoops. At 6, am I in the, yes, 6 seconds. I'm in the clear. All right. Now, that's a really basic problem. I will give you the formula. I gave you this formula. The next one's a little trickier, but I gave you the formula. I said, when does it hit the ground? Ground means the h is worth 0. The height is 0. Okay, and then I just used my algebra to solve this because it was quadratic, power of 2. I could factor or use the quad formula or something. Okay. Part B. Before I get to part B, how are you doing on this? I just kind of jumped in and dumped everything on you. You guys doing okay? Is there anything I can clarify?
So will the first t always be 0 since it started off at the ground, right?
No. If it started on the ground, yes. But we'll do this on the next problem. If it starts higher up and then comes down, then the first t will not be 0.
It'll be that first height it started.
Well, yeah. And actually it'll be negative. It'll be weird. We'll see that in the next problem. But in this case, the t is 0 and t is 6 because it starts on the ground and ends on the ground. That's why we got that one. Okay.
Gotcha.
Anybody else? Okay, here we go. Part B, same problem number 1, part B. It says, when is the height 48 feet? All right, this is a little bit trickier. When is the height 48 feet? Okay, so think about this. The rocket starts on the ground or whatever this is, okay, goes up. At some time, it's 48 feet. Okay, it's 48 feet on the way up, and then it hits 48 feet on the way down. So I'm expecting 2 answers. This rocket is going to go up in the air. It's going to get 48 feet high, okay, on its way up. Then it's going to hit what's called its vertex or its maximum point, turn around, come down, and it'll pass 48 feet on the way to crashing into the ground. Now, 48 feet is a height. 48 equals some height. So our equation will look like this. 48 equals negative 16t squared, I'll get it out of your way, plus 96t. So we're taking the same basic equation that we had here. That's our beginning equation for this problem. Okay. And we're saying, when is the height going to be 48? When is the height going to be 48? We're not going to change the initial height. We're talking about the overall height. That's different from the initial height. Initial height is when at the start of the problem. This height out here, h of t, is the height after a certain amount of time has passed. Okay, so we got this problem here. Again, my personal preference is I like my squared term to be positive, so I'm going to move everybody over here. And that's going to give me 16t squared minus 96t plus 48 equals 0. (16t squared), okay, because I moved over here, it becomes positive, minus 96t plus 48. Now, this is going to require us to use the quadratic formula. Okay, I can tell you that right up front. Okay. The issue is, do you want to use the quadratic formula with big, ugly numbers? Or do you want to try and use the quadratic formula with smaller, nicer numbers? Let me show you what I mean. If we factor out 16, okay, and now I understand it takes you some time, okay, to figure out that you could factor out a 16. What did they all have in common? Well, play around with them on your calculator. Eventually, you could divide out 16 out of all of them. So question, would you rather use this problem and use your quad formula with big, ugly numbers? Or would you rather use this problem and use the quad formula with smaller numbers? Personally, I'll take the smaller numbers every time. Okay or not okay with everybody?
Good for me.
Generally speaking, are we going to be able to do that problems?
You're going to pray. You should try it.
Okay, got
Yeah.
it.
Yeah. I mean, because looking at that going, holy crap, if I gotta go b squared minus 4ac with those numbers, I know I'm going to get screwed up. So if you can, even if you can divide out of 2, cool, divide out of 2. Okay, at least you have smaller numbers somehow. All right, so to use our quad formula, we know that a is worth 1 because a is a number in front of t squared. B is worth negative 6. C is worth 3. Okay, so we're not solving for x, we're solving for t, time. T equals negative b, so that's 6, positive 6, plus or minus the square root of negative 6 squared, that was b squared, minus 4 times 1 times 3. That's 4ac, 4 times a times c, all over 2 times a. So t equals 6 plus or minus, okay, a little bit of algebra here. That's 36 minus 12 is 24. So you should have 24 inside that radical. Okay, we're not done by a long shot. We have to always simplify radicals. Okay, that's going to be on this next test on Thursday. Can you simplify the square root of 24? Okay, so that's going to be 6 plus or minus 2 radical 6 over 2. I'm trying to save space here. So the 6 plus or minus square root of 24 becomes 2 radical 6.
Is it 2 radical 3?
No, it's 4 times 6 is 24.
Oh, sorry. My brain's not working.
It's okay. I have that problem all the time.
No, I did the 8 times 3. I get it. Yeah,
Oh, yeah, it's not the cube root, it's the square root. Yeah,
right. I did the same.
okay. So then this simplifies. Okay, remember we talked a little bit at the end of class last week. All of these reduce, all of what I call the normal numbers reduce. So what goes into 2, 6, and 2? 2. So if you divide everybody by 2, we get our final answer. Do I have room? Yeah. Of t equals 3 plus or minus the square root of 6. Okay, now we're not done, but we're done for now. We need to have some discussion, and I need to erase some of the board because we got some issues that we got to deal with. Okay. Are you guys okay with my algebra? Are you okay with all my steps?
Yeah.
With my algebra, anything up there? Could you do this on your own? Well, okay. There's nothing too shocking. I mean, you might have to think a while, but yeah. All right. Now, what if I said, round your answer to the nearest 10th? Okay. This is where I do need you guys' attention now. What if I said, round your answer to the nearest 10th? Round to nearest 10th. Okay, this is time, so it'd be of a second, 10th of a second, whatever. Those directions right there are a clue that, it's time to whip out your calculator, and you're going to be doing things like 3 plus the square root of 6 on your calculator. Now, some of your calculators, you can input that and then hit the FD key. So you can do on the 36X, you might have to mess around on other calculators. Clear, quit, clear. 3 plus square root 6. If I put enter, it just says it is 3 plus the square root of 6 is 3 plus the square root of 6. Duh. But if you hit the FD key, that will turn it into decimals. So you're going to get 5.44948. How do you round that to the nearest 10th? What would that be?
5.4, right?
5.4 seconds, right? So there's our first answer. Second answer, we go 3 minus the square root of 6 and hit the FD key.
I keep getting syntax error.
Which calculator are you using? Are you using
Yours,
the
I
third?
think.
Okay, because I'm just hitting 3 minus, I'm hitting the square root button and then the 6 button. And you're still getting syntax error? And what it does is it turns it into this. It reverses it for some stupid reason. Negative radical 6 plus 3. It does that to me. Are you still getting that syntax error?
No, but when do you hit the FD? button?
After you enter the whole thing, after you, what you do is you go, okay,
Oh, I know what he's doing. You have to press the over button and then the FD button. Otherwise, it puts it underneath the radical.
say again.
You have to press the right over, the right key, and then the FD.
Oh, you have to get out of
Otherwise,
the
it'll put
radical.
it underneath of the radical.
Okay, yeah, I didn't, you know what I did? Wait a minute, 3 minus radical 6. Okay, what you're saying is you got to press the arrow to get out from under the radical. So your cursor is out here somewhere. I just automatically hit enter, and that gets me out of there anyway. I didn't even think about it. So thank you for that. Anyway, then you hit the FD key, and I have point 0.5505, which rounds to 0.6 seconds.
For some reason, whenever I hit the FD key, it just gives me the same -6, the negative square root of 6 plus 3.
That's what's happening to me also.
Then hit it again. Try hitting.
It
The
doesn't do.
calculator I have to hit the arrow
No.
keys over the enter button.
Yeah, that's the FD key, isn't it?
No, my calculator is different. My FD
Oh,
key is
okay.
right there.
What would happen? Okay,
Professor, isn't the FD to the second function?
yeah, but you don't have to do it.
If you
I-
do
I-
a function of
You
this,
just push
put
that.
it on the
You just
back.
push that button above the enter, which is what Vincent was
The
saying.
equals.
Yeah, the squiggles.
Is that what that squiggle is? Okay, I can't
Yeah,
see
and
it.
if I hit the squiggles, it just goes back and forth from negative, or the decimal and then the radical. Just keeps going
Right,
back
that's
and
what it's
forth.
supposed to do.
Yeah.
Yeah, it bounces back and forth. So I'm hitting the FD key, but I'm not hitting shift. So what you guys are telling me is that you should be hitting the key that has little arrows there with a double squiggle, which is right above the enter key.
Oh, I see. I was hitting the
Yes.
second blue key
Yeah,
first.
and that is my fault because I said FD and it was blue. So that should tell you that, yeah, you were following my directions. I was wrong. I'm just hitting that silver button right above enter, which is what Vincent was saying a second ago anyway. And I'm not doing all the fancy crud. Okay, so wait, let's go back. Are we okay with taking a square root problem, 3 plus square root of 6, and turning it into a decimal problem, decimal answer? You guys all got that now or not?
Yeah, I got it now.
Okay, good. So wait a minute, what do these two answers mean? Let's go back to our original problem. What do these two answers mean? Remember, we were looking for, when was it at 48 feet?
The 2 times they hit 48.
Right. So at 0.6 seconds after it was launched, it hit 48 feet, and then went up and came back down. And at 5.4 seconds on its way down, it also hit 48 feet, because that's what those two answers are. Okay. So you need to read the directions. If it says, give me the exact answer, this is the exact answer. Okay. If it says round, then you have to use the FD key and round it out. Now, mom is a little bit weird. Email me if you're having problems. It doesn't say it, but I believe if you take her out to 4 decimal places, you're okay. If it says approximate the answer and you go to 4 decimal places, that seems to be working, but I've had no consistency. Sometimes mom just automatically goes to the 100th, to the 10th, whatever. When we come to a quiz, I will go back and hand grade all of those decimals for you. Make sure everybody gets it right.
Is there a
Okay.
particular way to write those answers?
What do you mean?
Like
Well,
like the first and then the second launch point, or
okay, if this were high school, which it's not, remember I could intimidate the little high school boogers all the time. If they didn't write a complete sentence answer, okay, they lost credit. So if this were high school, I would say the rocket reaches a height of 48 feet at 0.6 seconds and 5.4 seconds. That's all you have to say. The rocket reaches a height of 48 feet at 0.6 seconds and 5.4 seconds. And that's it. You get full credit. But in high school, I could intimidate. I had a lot more control over students. And I don't want to do that here. So as long as you tell me these 2 answers, I'm happy. I would prefer some kind of even partial sentence, but that's my own problem, not yours. And I know most teachers would also. Okay, so Richard, I'm not sure I answered your question, but are you okay?
no, that was it. That was
Okay.
it. Thank you.
All right. Well, all right, let's try number 2. I need to erase this. We'll do number 2. Okay, so if somebody could put number 2 into the chat while I erase. All right. Blah, 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 blah. This is number 2. Blah, 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 blah. Number 2. Okay, the first thing I do is I read all this crap and I see the formula. H of t equals negative 10 t squared plus v naught t plus h naught. This is, Mitch, to answer your question from a while ago, this is probably how I'm going to show you every one of these problems on a test or a quiz. I will give you the gravity statement, okay? You just live with it. You don't have to go a half, you don't have to do anything. That's there. Now, let's read this problem again on number 2, because we need to fill in V naught and H naught. So it says, on a distant planet in a galaxy far, far away, a princess stands on a hill that is 120 meters above the sea level and throws a stone into the air with a velocity of 40 meters per second. Okay. Well, what's that tell me? If this is the initial formula, what can I fill in?
Good
You should
question.
answer that.
Is it
Okay.
negative 10 because it's gravity?
Yeah. And I will give you that. And like I was telling Mitch, you just live with that. If I give you negative 10 t squared, you just go, okay, negative 10 t squared. That's the gravity part. So what's the initial velocity?
40 meters per second.
40, yeah, plus 40 t. So the V naught, meters per second is speed, miles per hour, meters per second. That's speed, that's velocity. And she was standing where? Oh, 120 meters above the sea level. So again, this is what you're going to see on a from me is I will give you the basic formula, which includes the force of gravity. So you never have to worry about that. But you have to read the words and pull out what was the initial velocity and what was the initial height and fill them in. This then becomes the formula that you're going to use for this problem. Okay. Part A, when does a stone's height reach 100 meters? Okay, part A, when is height equal 100 meters? Okay. Where's the only H I can plug it in for? The front one? So our work would start like this. 100 equals negative 10t squared plus 40t plus 120. The height is 100 meters at some time. It said when. So at some time, t, we don't know when, the overall height will be 100 meters. So that's what we wrote there. Okay. Make it equal 0. So I added 10t squared to both sides, subtracted 40t from both sides, subtracted 120 from both sides, and I get this problem. Okay. I can factor out a 10. I see that. So I have t squared minus 4t minus 2, equals 0. Okay, so you have a question. You're going to have to use the quad formula on this. It's just plain ugly. Okay, so the question is, do you want to use your quad formula on this problem before you factor out the 10 or on this problem after you factor out the 10? And I take this second one. Yeah, I'm sorry, go ahead.
No, you're fine. You're fine. Thank you.
Okay, so t equals 4 plus or minus. Tell you what, why don't I pause this while you guys apply the quad formula to solving that equation. I'll pause it for a few seconds. Okay, so I went ahead and did a couple of the steps. I identified my A, B, and C values for the quad formula. I plugged everybody in, and eventually I got 24 inside the radical. Okay. Again, I've said repeatedly, if there's one place students make dumb mistakes, it's inside the radical. It's that PEMDAS. Negative 4 squared is 16. And this is minus a minus 8. 16 plus 8 is 24. But people just screw up here. You don't trust your own math, or you trust the computer or the calculator and you type something in wrong. That's the one place that people screw up. So simplify the square root of 24. We get t equals 4 plus or minus 24 is going to be 4 times 6. So I can take out the 4. So that's 2 radical 6 over 2. Okay, for those of you not sure what I just did, 24 is 4 times 6. So the square root of 4 comes out as a 2, and the 6 stays inside. Okay. I can reduce everybody. So this is t equals 2 plus or minus the square root of 6. Boom, boom, boom. Okay. And those are considered my exact values. Okay. But what's it going to be? Again, If we go to the nearest tenth, it'll be 4.4. What's my time? Seconds, minutes, seconds, seconds. Or pardon me? Or
0.44. 0.45.
I get negative.
So did I was gonna ask you
Yeah,
about
it's
that.
negative 0.45. That's what I got.
Oh, okay. Negative 0.45. That's an important thing. Okay. Okay, and this comes back, Vincent, to your question.
Can you write down?
Oh, I'm right in the middle of the glare, aren't I? Okay, sorry. So 4.4 seconds or negative 0. I'll call it 4 seconds also. I didn't tell you what to round to, so you can't be held accountable for anything. Is that showing up? Yes, it is. Okay. First question to everybody is, did you all get those? Did you get that radical answer, 2 plus or minus radical 6? And were you able to convert it into the decimal form?
Yes.
Any questions about that?
I have one, sorry.
All right.
So when you reduce it from 4 plus or minus 2 radical 6 over 2, what
Mhm.
exactly are you reducing to make it 2 plus or minus radical 6?
Okay. You're 4 plus or minus 2 radical 6 over 2. What you're saying is all of the normal numbers can be divided by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1 radical 6 over 2 divided by 2 is 1. So I'm dividing the 4, the 2, and the 2 all by 2s. And I
see
get
it
this
now.
answer.
Yeah, the ones, how it was turned to 1 and then you took the ones out because you don't need them, that kind of threw me off. So
Okay.
I
And
see it now.
that becomes a good question. Good.
Thank
Is
you.
that okay with it? Is that okay with everybody? All right.
Yeah, Professor.
Yeah.
For some reason, it could be just the my calculation over here with a calculator. I get a 4.8989 for the first positive input instead of 4.4. Am I doing something wrong?
Yeah. Are you doing this problem or are you doing
Yes,
it
that one. The
2
positive one.
plus, okay, 2 plus square root 6, arrow to the side, hit enter. And then hit FD.
Oh, okay. I got it.
I think Mitch's, okay, I'm sorry.
I wasn't putting in the plus sign. The 4 plus, I mean, or the 2 plus, yes, okay.
Yeah, you were technically doing 2 times radical 6.
That's what it was. Okay, thank you.
Oh, okay. Anybody else? All right. So think about this problem. The princess is standing at 120 feet. She's above sea level. Okay. She throws the rock up in the air, it comes back down. Okay. What this is saying is, when was it at 100 feet? Well, wait a minute. Stop for a second. If it started at 120, how is it ever going to be at 100 feet? Okay, if our problem started at 120 feet up and then she threw it up and it came back down, when is it ever going to be at 100 feet? Because 100 feet is lower than 120. Okay, so that's this one out here, or whatever it was, 4.4 seconds. It'll hit 100 feet on its way down. Okay. This is where you guys have to be more intelligent than your calculators. The calculator just knows that or the math, the algebra just says, hey, they're doing this silly parabola. It doesn't really know that the problem starts at 120. It's thinking, oh, this is a full-on parabola. It goes up, it comes down, and it goes down forever. As far as the algebra is concerned, this parabola goes forever down like this. So for the algebra, the negative 0.4 is great. That's a fine time for the algebra, but not for reality. Reality says, our problem started here, and we could never hit 100. So there's a difference between algebra and reality. Okay, because we have a quiz tonight, I want to jump down to Pythagorean Formula. We've done those in the past. I think we'll have time to do one of those tonight. Okay. What about the Princess one? When does it hit the ground? How would we modify our work? What would our equation look like if we did part B to know when does it hit the ground?
Would the 120 part be 0?
Nope.
instead?
Nope.
No?
The 120 is built into your formula. You got to
Mhm.
start with that.
Okay.
So what's the only other height that we could change?
The
H of
height,
t?
mhm.
Yeah, h of t. Okay. The 120 is your formula. You're stuck with that formula. The only thing you can do is either put a value for t, or you could say h of t is 100, which is what we did here. Okay. So on that one, on part B, if it hits the ground, your equation would be 0 equals negative 10t squared, I'll get out of the way, plus 40t plus 120. I apologize for squeezing it in there. Because when it hits the ground, that means h is worth 0. So we don't have time tonight to do all this, but that's how you would do that equation. So you might want to work it out. Did anybody download that worksheet? I think I put the answers at the back end, didn't I?
You did.
I did. So you can double check, see if my answers are right or if you can get my answers. All right. I want to set up the one Pythagorean and then we'll quit for the night. Okay. Pythagoras, number 3. This is the hypotenuse of a triangle is 3 more. Again, if somebody could put this in the chat, 3 more than twice the longest leg. So here we go. Right triangle, twice the shortest leg. So X is going to be my short leg. Okay. Now it said the hypotenuse, okay, which is this leg, this side out here, is 3 more than twice the shortest. So twice the shortest is that. Twice means 2 times. 3 more means 2 times that plus 3. So this is the expression that we're going to use for the hypotenuse. 3 more than twice the short side. Short side was this. Okay. The second leg is 7 more than the short leg. So this will be X plus 7. Okay. So reading the problem for number 3, that's my initial setup. one of the legs is x, one of the legs is x plus 7, and the hypotenuse is 2x plus 3. Does that English make sense to everyone?
Yes.
Okay, then to use Pythagoras, recall the formula is leg squared plus leg squared equals hypotenuse squared. So it's x squared plus x plus 7 quantity squared equals 2x plus 3 quantity squared. Now, when we did these earlier in chapter 7, which is when we introduced this, I had to be very careful how I wrote this, because I had to make sure that when we foiled all of this out and added like terms and made it equal 0 and all that other crud, I had to make sure that the result factored. Now I don't care. We have the quad formula. If it factors, great, factor it. But if it doesn't factor, go to the quad formula. Okay, so let me pause this. I'll work through it. You work through it. See how we get. Make sure we all get in the right answer first. Okay, so after all my talk and bluster about I don't care if I make the problem work out nice, blah, 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 turns out this problem worked out nice. So maybe I should just shut up. So I got it down to here. I was able to factor out a 2, made my number smaller. I kind of, something in my brain says, hey, it factors more. So I factored it. Okay. And I got 2 answers, x is 5, x is -4, reject that, because we talked about that way back in chapter 7. How can the side of a triangle, this is where math and reality conflict with each other, how can the side of a triangle be a negative value? Okay, it can't, so we reject it. Any questions down to my 2 answers, 5 and -4? Anybody have any questions down to that point? Okay. Then the question doesn't say, oh, actually, what's the question say? Find the area and perimeter of this triangle. So let's look at what we have here. Okay. If x is 5, x was 5, this is 5 plus 7 is 12. 5 plus 7 is 12. This is 2 times 5 plus 3 is 13. So that's my actual triangle, 5, 12, 13. Now the problem says I want the perimeter, okay, and I want the area. Well, perimeter is easy. It's 5 plus 12 plus 13. So I don't know, whatever that is, 30. Did I have units on there? I said assume meters, 30 meters. Okay. Now the area is a little bit trickier. The area is 1/2 base times height. That's the formula that you guys should be able to pull out of thin air. Okay. Question. How in this formula, I need everybody's attention for a second. Okay. So Mitch, stop guzzling. When we write base times height, what is their assumed relationship? How are they oriented to each other? I'm cutting up with
Multiply.
all. Well, that's what they mean, but who's the base and who's the height?
12 is the base, 5 is the height, right?
Yeah. Okay. So what I was getting at was when we say base and height, we mean that the base and the height are always perpendicular to each other. When you see base times height, do you guys ever see a triangle written or drawn something like this? And they put an extension out here. Okay. they extend it with dotted lines and they say this is 4 and this is 9. You ever see that? When people ask you to find the area of a triangle where they extend to the side, that's because the 9 has to be at right angles with the 4. You couldn't use this side because it's not at right angles. So if you're going to use this formula, then the base and the height are assumed to be at right angles to each other. Otherwise, you got to come up with another formula and they'll hit you with that in trigonometry. But this formula assumes base and height are at right angles to each other. So we have 1/2 times 12 times 5. That's also 30, but because its area is meters squared. Okay, tomorrow night, I want to do a couple of more word problems at the beginning of class. Excuse me. A couple more word problems at the beginning of class. Maybe 1 or 2 review questions from my end. Okay. But then the rest of the night will be left for you guys to ask me review. After I've done my new stuff, my new lecture, if you've got no questions, you can check out. Okay. If you have questions, you can stick around and ask me tomorrow night. If we finish at 7:30 tomorrow night, that's fine. If we finish at 7 o'clock, that's fine. But that's your shot to ask me tomorrow night. So come loaded with questions tomorrow night. I've got the quiz set for 8:10, I think. So you have a second to go get something to drink, to go to the bathroom, come back. Basically, I'm done tonight, guys.